start recording and we will start soon. We have 6 participants for now. You see some preparations, a few moments, and we will start our session. Yeah. Then, hello again, dear colleagues. We are really happy to see you here on section 3, Applied Intelligence System. We have such special occasion. Happy to see you here this time virtually. And I will remind you a few moments rules of the meeting. We have 40 minutes session and 5 minutes for short report presentation and 5 minutes for discussion. Yeah. Then it will be at least 4 reports per this short 40 minutes. Then we will have a short rest, and after at 14 o'clock second session and 15 o'clock maybe that it will be already all together, all sessions together is closing conference. Then let me start. First report is conceptual model of information system for drone monitoring for trees condition. Vasyl Lytvyn, Alina Dmytro, Andrei Berkov, Vladislav Alexeyev, Taras Basyuk, York Rainer Nerning, Dmytro Peleshko, Taras Rak, and Viktor Voloshin. Please, who will be reporting? Microphone, please. Not listen.
I'm not ready, but I'm only co-author. I think my colleagues will connect to our meeting, and anybody can make a report.
Okay, okay. Then maybe people looking at this report YouTube, and YouTube. Somebody have any questions for this report? No, if nobody, I have one. What is the main significant demand for drone to be used? Minimal price, which will be expected, because it's quite a complicated drone, should be. No? One again, microphone.
Maybe. It's a perspective project, but practical features of this project is now not discussed.
Okay. Another one. Is it real-time processing, or afterwards it will be processing results?
Yes, it is. It have to be a real-time processing.
Real-time. It's quite complicated, maybe.
Yes. We think it will be a great project, and we only discuss any features of this project today.
Okay, okay. Maybe somebody else have questions to the authors. Have not, yeah? Thank you very much.
Don't mention.
Then we going to second report, development of traffic flows and smart parking system for smart city. Anatoly Katrenko, Irina Krislata, Oleg Veres, Oksana Oborska, Taras Basyuk, Andrei Vasylyuk, Igor Rishniak, Nazary Demyanovsky, Oksana Mech, who will be a reporter. No, we have not. Okay. I will mark. Okay, next one. Econometric analysis of the impact of expert assessment on the business activity in the context of investment and innovation development. Rostislav Yurinets, Soriana Yurinets, and Mariana Kohan. Who is from the author? No, I cannot see. I have a question to both previous reporters, but sorry, not present, yeah? It will be short session, let's see. Next one, an intelligent system of commercial distribution of information products based SEO and Sitecore CMS. Богдан Русин, Любомир Погрилюк, Олег Капшій, Ярем Оверецький, Андрій Демчук, Ігор Карпов, Олександр Гожій, Віктор Гожій, Ірина Калініна. Anybody? Nobody. Okay. Then, third is absent. Fourth. Information system for recommendation list formation of clothes style image selection according to users' needs based on natural language processing and chatbots. Vitaly Husak, Olga Luzynska, Igor Karpov, Ivan Peleshchak, Sofia Cherun, and Anatoly Vysotsky. No? Sorry. Fourth, no. Five. Third, development of information system for aggregation and ranking of news taking into account the user needs. Vasyl Andrunek, Lilia Cherun, Andrei Vasevich, Nadia Chernovol, Natalia Antonyuk, Alexander Gozhy, Viktor Gozhy, Irina Kalinina, Maxim Koropchinsky. Absent, no. Five, no. Why next? Five. Developing an intelligent online learning system for foreign language vocabulary training based on gamification. Vasyl Andrunek, Maria Hrendus, Yuri Rashkovets, Maxim Yavir, Andrei Hudy, Viktor Hrigorovich, and Maxim Koropchinsky. Are present authors? Not present. It's very fastest session I know. Next one. 5 absent. 6. 6 to 9. It seems to me from 6 to 9. Yeah. Nobody present, it seems to me. From 6 to 9, development of information. Maybe we change our agenda and starts from present authors. What do you think? Because we have, how much? 7 participants. Without me, 6. We can listen 6 reports and...
Yes, I agree.
Agree. Okay. Then who will be first? Oh, already 5. Andrei Berko minus and 4. I know that Miroslava Bublik has reports.
Yes.
At least 2 reports, yeah?
Yes. Yeah. Short
You
reports.
You have a lot of time.
Should me present the presentation or
If you please, as you wish.
Yes, okay. Ladies and gentlemen, let me introduce our research on the topic Intelligent System on Visual Simulation of Passenger Flow, done by Associate Professor Victoria Vysotska, Yuri Matsyryuk, and Professor Vasyl. The most important problem in smart city development is the public transportation, that is term is not sufficiently guided by the modern intelligent system. The large number of passengers who use public transport make the movement with its help to form the concept of passenger flows. Passenger flows depend not only on the further of the route, but also on certain major points of the largest passenger flows in the city. Passenger flows are the most important aspects that must be investigated when creating new routes and connection updating for modifying existing pumps. Visually, see problem areas. Sorry, I have information that my co-author wants to present this presentation, and sorry, I start present my next research. Okay, sorry, it's miscommunication. Sorry, it's really.
You have 2 presentations different.
Yes. Sorry, I will start the same again. The next presentation. Okay, it's very interesting situation. Sorry. Okay, now I will introduce your research on the topic Intelligent System on Passenger Transportation by Autopiloted Electric Buses in Smart City, done by Miroslav Bublik. It's me, Yuri Matsyryuk, Associate Professor Juliana Motornyuk, and Associate Professor Marta Tereva. The most important problem in Smart City is improving the quality of passenger transportation. And improving the quality of passenger transportation, including indicators like timely arrival and departure of public transport, safety in passenger transportation, reduction of harmful emission of harmful and greenhouse gases to the people, improving the general environmental status of the settlement. The main purpose is to create an intelligent system on self-piloted passenger transportation by electric base aimed at solving the problem of the concept of the smart city in the field of the public transport. This will increase the standard of living of urban population and make more produced use of the resources. On the base of the purpose, the following tasks we allowed: to investigate how information systems in the field of urban transport management, analyze existing software products in the area of passenger transportation and cargo transportation, and to develop the intelligent system of passenger transportation by autopiloted buses in a smart city. Analyzing the concept of smart city in the leading cities of the world, Boston, New York, Bodley, Buenos Aires, Amman, Sydney, we can conclude that public transport is one of the key areas where the use of IT is rapidly due to the integration of physical infrastructure cities with digital based on big data technologies. Autopiloted electric buses are being developed by leading companies in the world, including Tesla. The autopiloted electric bus information system is virtual non-existent. The proposed intelligent system of passenger transportation by autopiloted buses uses 4 external entities, namely passenger, bus, operator, and server. The ISPT, it's a short name of Intelligent System Passenger Transportation by autopiloted ecobuses has been developed, the work on which is decided in an UMA environment. The data flow associated with the passenger include: first, passengers requires for travel, which corresponding to the requirement to stop the autopiloted bus at the appropriate stop, payment and confirmation of payment by the passenger. The data flow associated with the bus include: request the bus to stop to the next stop, constant transmission of the exact location of the electric bus every 5-6 seconds, data transmission of all bus support systems such as battery charge, the timer pressure, or any other emergency, received from the system of correction or other status. The data flow associated with the operator includes some three-stage and the main process developed of ISPT include 5 processes: query, formation, pair, stop sequence formation, conditions control, emergency management. Based on the need to solve, the key task of the improvement the quality of service is the development intelligence method to urban passenger presentation. On this result, we have the figure presented a constructed diagram of state transition, which shows the process that take place inside the ISPT. The design of the specification of the management of the ISPT by self-managed ecobuses. We use the state transition diagram, the state transition metric subject of successful payment of the fare is constructed on the series of tables, and as a result, in conditions of smart cities, the list of tasks of the public transport information system include improving the quality of passenger service, increase their capacity, accessibility to resource, optimization of passenger transportation. And as a result, we obtain optimization of the operation of public transport by means of self-driving electric ecobuses have been solved the corresponding quality of the passenger transportation, appropriate the composition of the passengers with possibility for control and processing both normal and emergency conditions, have been improving the safety of public transport. Thank you for your attention.
Thank you very much for your report. Maybe somebody have questions to report. I have one, at least one. This is real-time system, yeah, of course.
Yes,
Because
yes.
the data needs to be done. Now, any logging of
No, any logging.
Yeah.
No. Yeah, especially for government, or especially for passenger, or especially for not logging. Yes.
For government, yes. No.
Yes, for government man, for government people. Yeah, sorry.
Some authorities from local.
Authorities. Yes. Yes.
Okay. Then another one question. What about reliability of this system? When some problems with electricity, some servers working, some servers not working, all transportation is stopped in this situation.
Yes,
Because information.
questions we think about this, and now we think that it can be solved by special point state with the auto ecobuses can to get chargers. Some construct the stop buses where they can to charge some problem. But with server, it must be a problem decided as charging, supply charging, second charging.
I think it's dangerous to centralize such system, because it's every time have vulnerabilities for
yes. It's very real problems. Yes, we agree. Yeah.
As to now, we see
we
that
still thinking about it. Yes.
Okay, thank you very much.
Thank you very
Maybe somebody else have another questions.
Hello everybody. My name is Thierry, and I want to present you my theme called Information System for Socialization by Personal Interests on the basis of Cell Technologies and Methods of Machine Learning, created by Thierry, Victoria Vysotska, and Vasyl Lytvyn.
Choreographic settings.
What?
Choreographic, yeah. Which report?
Information System for Socialization by Personal Interests on the basis of Cell Technologies and Methods of Machine Learning.
Okay, please.
I want to shortly tell you about this system. The main purpose of the study is to create an informational system for the socialization of individuals using fuzzy word search algorithms using the noisy channel model with algorithm for efficient textual information distribution, and using a convolutional neural network to identify system users, since there is no such system in the present that would analyze the user-specified information and form a list of the most relevant users. Creating an information system for the socialization of personalities is an urgent task, since in the modern world people try to optimize all life processes to save time, and accordingly for more expanded realization of time saved. When looking for programs users, first of all choose the ones that save time, that are optimized and automated enough to do most of work instead of the system user. This information system combines two important tasks: socialization of user, and optimizes and automates the process of socialization as much as possible. Talking about the system, I can tell you that it consists of 4 main steps. First step is simple authorization and user registration and then authorization, because we need to have an authorized user inside our system. Second step is user must to fill all information about himself. It's the short description, his interests, and he must to write what person did he want to find her in this system. And of course, he must download his photograph. The third step is system analyze all the users inside the system and the current user, and it makes a list of divided by percentage for this user. For example, first of all, we can see the user that are most current with our user, and the last will be the last. And of course, we can like this user, we can write him a private message, and we can just socialize with him. To talk about algorithms, there are two main algorithms. First of all, we use a Lytvyn algorithm and noisy channel to analyze user text. And a second algorithm is we use a special convolutional neural network, because we need to understand if we have a real user in our system. We need to analyze user photo. First of all, we need to find if there a human face on the photo, and second, secondly, we need to find if we have the same user in the system. So to summarize, I can say that in today's world, users are first and foremost looking for user-friendly and intuitive systems that can perform certain actions for them, thereby saving user time. The system for socialization of personal interests of the common interest overtakes the program of analogs, because in the first place, it guarantees the identification and authenticity of a photo of a user, and also it optimizes the process of finding user by analyzing all others user on a common interest and forming a percentage ratio that allows you to quickly determine your degree of similarity with other users and have an approximate idea of how much your interests are in line with those of other users. So thank you for your attention.
Thank you very much for your report. Sorry, I can see you, but any questions? Maybe somebody else have questions beside me. No. I have one question. Could it be used for example, alcohol-dependent person groups, for example?
What do you mean? If you mean
for looking for some, I don't know, common interests beside alcohol, for example.
Oh, I think it can be used. It can be used for all. But first of all, there are two main fields that users have to describe. It's their main interests, users that want to find, and the short information about themselves. So I think if they will in their interest field, they will write that they're finding users who like alcohol. So yeah, it can be a system for finding some users like that.
Okay. As for me, mainly it's oriented on looking for partners, or I'm wrong?
Yes, it's one of the proposals, but also you can find just user to talk about something. For example, you just recently watched some interesting film or read some interesting book, and you have no one to discuss about it, or you just like some, for example, you like fantasy books, but you have no friends to discuss your favorite books. You can, in your interests, mainly write that you want to find people who like that authors, who read the books, and who want to talk about it. And the program will find users that are the most similar to have interests most similar to your interests. But it also, yes, you're right, you can just find some partners, for example.
Okay. Thank you very much for your report.
Thank you.
Then, anybody else want to make reports? We are ready to listen.
Hi. Let me introduce our research on the topic intelligent system of visual simulation of passenger flows, done by Associate Professor Vysotska, Yuri Matsylyuk, and Professor Maslava Buk. The most important problem is smart city development is public transportation, which in turn is not sufficient guided by modern intelligent systems. The larger number of passengers who use public transport and make their movements with it helps to form the concept of passenger flow. Passenger flows depend not only on the features of the road, but also on certain major points of the largest passenger flows in the city. Passenger flows are the most aspects that must be investigated when creating new roads and connections, updating and modifying existing ones. Visual simulation of passenger flows will help solve the following tasks. First, visually see problem areas on roads. Second, identify major stops with the highest passenger flows. Third, decide quickly on the need for road upgrades. Fourth, obtain passenger flow forecast for the quantity and quality changes of a vehicle. There is two software passenger traffic visualization available in the internet. First, possibilities of visualization of passenger traffic in the sphere of public transport are provided by company A+C Ukraine. And the second, there is a 3-month visualization of data and the sale of electronic tickets in the city of Zhytomyr from the website texty.org.ua. The development intelligence system works with the most up-to-date data, downloading it to the user's request from the servers of the city. The data is cached and does not require further updating. The creation of additional files for filling occurs in a fully automatic mode, where the users needs to fill in the data either in accordance with a specific template which is created specifically to unify the process of interaction between different systems or in accordance with the international standard GTFS. The main screen of the software is interface shown in a specific chain elements principle, which indicates this type of interface. When the users cannot click on buttons that are responsible for processing data that does not yet exist. In the absence of data, it will only be shown to download the new data. After selecting the road and its type, all the buttons and fields will be activated. Regarding to the international interaction with transport forecasting, there is a separate block on the right side of the main menu in which you can train the neural network, after which it will be saved and will not require retraining. The program also creates a template file for submission of information in GTFS format, which should fill the users with a new additional transport schedule. To summarize, the paper investigates a number of existing passenger software products on the market. It is established that the key task of public transport information system is to evaluate passenger traffic, their possibilities, accessibility, principles, and principle of optimization of public transportation. Thank you for the attention.
Thank you very much. Any questions may be present? I have one question. What is the amount of parameters you record, and what is the frequency of sampling?
Okay, the three types of parameters. We have such parameter as the general parameters of a whole road. It contains mostly up to 10 different parameters, which includes special, how much people drive on this road, how much people took this road this day, how long is this road, how many stops people in average travel in this road. The second is special information about each stop. On each stop you can see the a passenger flow, how many people sits in, sits out in any hour. You can see how much it's depends to constructal capacity of vehicle or full capacity of vehicle. And the third parameter, it's depend on distance between stops. Because this is distance between stops, you can see how many people traveled on this distance, and you have maybe remember four parameters: how long it is, how long time it is took to travel, and how long it is in distance.
It's all about people or about car too?
It's about road, about stops, and about distance between stops.
No, but
people are
people, yes. Taking a system takes into account people or car tours.
No. This system is not developed for a regular user. It's developed for private companies or government, such as Lviv ATP-1. So you need to take real passenger flows data from the world. There is two ways to get this data. You can count it on the stops, but or you can use automatic system which you mount into vehicle frame to count passengers, and then this program will show all the results.
Okay. Also about payment by passengers too, information taking or not? Payment.
No, this is not constructed to take from the payment, because payment is not for all people, and many people decide to buy paper tickets, not to electronic tickets.
Okay. Another question again: how often, how frequency of sampling? 2 times?
1 day.
Once a day?
Yes, 1 day. You take info from the bus route for the day, and then you can analyze them.
But during the day,
but during the day, it's dedicated to period in 1 hour. So if there is 18 or 16 hours of work time, so you will have 18 or 16 hours of dedicated data frames.
But data frames, once an hour or 10 times an hour, or how frequent?
No, if you want to load information in your system, you need to get information from 1 full day, and then the program will divide it by hour by hour date frames. You cannot load information about 1 hour of the day, but you will get this information if you load full day information.
Mm-hmm. Okay, thank you. Another questions. We remains 3 minutes before system interrupts us. Then, if nobody else has a question,
No question.
Yeah, then I would like to thank you for participation. Yeah, and invite to join us at 3 o'clock again. Somebody will start conference session. Vasyl has problem with electricity, therefore it's possible that he will not possible to open session, but maybe Tatiana will open. We will wait for next session. Thank you very much for your attention.
Thank you very much.
Thank you. See you next time.
Thank you all.